Hello, welcome to our next set of notes. We're starting Unit 2 today with Section 5C. We're going to go over some tables and graphs. We're getting ourselves into statistics, which is going to be the main section for Unit 2. Most of Unit 2 will be in Chapter 6. We're just going to start off and have one section in Chapter 5. So we're going to start off talking about some statistical tables and graphs, things that we use to display data, because that is a big part of dealing with statistics. One table you should really be familiar with, that you should be ready to do on the exam, is the frequency table. So here's a list of grades from a math class, and then some questions. They want to know, is the class doing well overall? What grade is most common? And you can figure that out. If you look long enough at here, you can kind of see, what grades are more common. You can see overall kind of how the class is doing, but it's not that easy. You have to do maybe a bit of counting and figuring things out. So it might be easier if the data is displayed in a more meaningful method. So let's use a frequency table to show the data. So a frequency table consists of two columns. First one just gives the categories, so the different categories of your data, and then the second is the frequencies, or the number of data values for each category. So we're going to make a frequency table. So first we're going to have the grades will be our first column. So we're going to have grades, and then the frequencies, which is basically just counts. We're just going to be counting how many. Of course, frequencies, the grades for this, the categories would be A, B, C, D, and F. Those would be your categories for here. Okay, we have, let's see, we have 1, 2, 3, 4 A's. Make sure I didn't miss any. So 4 A's. We have 1, 2, 3, 4, 5, 6, 7 B's. So we have 7 B's. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 C's. So we're at 9 C's. And we have 1, 2, 3, 3 D's. And for F's, we have 1, 2 F's. 2 F's. So this is a frequency table. Not that difficult, pretty easy to make, but it's useful. It's very valuable because now we can look at this. We can easily say that the most common grade is a C. It doesn't take much work besides looking at the table. We can see that the class overall is doing pretty good. The only 5 students in the whole class have D's or F's. The majority of students have A, B's, or C's. Only 2 people are failing, so it's not bad. It's pretty good for a class. Lots of classes. C is average. That's pretty typical for school classes, and that's what this is. Now we've seen the data presented in the frequency table. There's some questions that are really easy to answer, the ones we just did. However, there actually are still some questions that are not as easy to answer. They take some work. For instance, what percentage of the class is failing? How many students are getting a C or higher? We could figure those things out, but it'd be nice if those were presented in the table. So we're going to add relative frequencies and cumulative frequencies to the table, because those will give us more information. So relative frequencies are fractions, or you can remember this percent. I'll put both on my chart on the homework on the exam. You just do one or the other. You don't need to do both. And then cumulative frequency is the number of values in that and all preceding categories. I think of it as a running total. You start from the top and you just add things up as you go down. So one of the common mistakes I see on the test is people trying to do cumulative frequencies in kind of percent or fraction. It's not. It's just a running total. It's a whole number. Shouldn't be a fraction or percent. Relative frequencies, that is your percent or fraction. So relative frequency is a fraction. So first off, you need to add up. So this is that same data I just put in a chart for us already. There were 25 students total. So to make my relative frequency, I'm just going to take the frequency of that category. So 4 people got A's, and divide that by the total. So I have 4 out of 25. 7 out of 25 for B's, 9 out of 25 for C's, 3 out of 25 for D's, and 2 out of 25 for F's. To get percentages, we're just going to go ahead and divide those. So I divide 4 by 25. I get 16%. Don't forget to turn that into a percent, not a decimal. We do 7 divided by 25. We get 28%. Next one is 9 out of 25. 36%. 3 out of 25. That's 12%. 2 out of 25. That's 8%. If you add up your percents, you should get about 100%. Now, sometimes you might get 99 or 101 just because of rounding. You know, this time I didn't have to round, so big nice numbers. But a lot of times you'll end up rounding. But if you add up the relative frequencies, you should get pretty close to 100. Now, if you don't get exactly 100, that's probably from rounding. But if you're getting pretty close to 100, if you're getting 99, 101, 100, that's okay. Cumulative frequencies, like I said, is the running total. So with cumulative frequencies, we just start off. There's 4 people with A's or better. Then for B's or better, we just add the 7 onto that for us. We have 11 people with B's or better. Add 9 more, and we have 20 with C's or better. Add 3 more, and we have 23 with D's or better. Add 2 more, and we have 25 or more to have F's or better. Of course, the last row, the last category should be everybody, so it should be the same as your total. If that doesn't happen, you're doing it wrong. So it makes sense that it's 25. So relative frequency, cumulative frequency, you can see how those are useful. Now we can look at that and say, well, the percentage of that are failing is 8%, so less than 10%. The number of students that have a C or higher, well, that's 20. So that data, we can answer that kind of question. Sometimes you don't want to know just the percentage of the number in one category. You want to know the number of categories that are passing or better than a C or things like that. So now we have all that information. So frequency table is pretty simple, easy to put together. You got to remember that relative frequencies are fractions or percents. On the test, I'm not picky about which one you use. You can do fractions, you can do percents. The homework will specify whether they want a percent or fraction, so be careful, watch for that. And the cumulative frequencies, again, just a running total. So you should be ready to make a frequency table. Now, before we get too much into other charts and graphs, we do need to talk a little bit about data types. You'll see this show up in the homework as well. So data, statistical data, when people go out and do surveys and collect data, it really comes in 2 main classes or flavors, if you will. There's qualitative data and quantitative data. So qualitative data, you have to remember, qualitative data is things that are categories or qualities. They're not numerical. Typically, they're not subjective. They are subjective. They're not numerical. Or it's subjective. So sometimes they can be numbers, but they'll be like subjective numbers. So qualities are categories. I think I spelled categories wrong there. Oh well. And then this is non-numerical or subjective. It can be one or the other. So things like eye color, hair color, what kind of car you drive. But it could be numbers if those numbers are labels. They're not like things you count or measure. So if you have, I don't know, 4 groups of students in your class and the teacher assigns the numbers 1, 2, 3, 4, and then she does a survey and you have to answer with your group number. And if you're group 1, group 2, group 3, group 4, you're not really counting or measuring, that's a label. So that's, could be a number if it's not a count or measure number. Because if it's count or measure, then it's going to be quantitative. So quantitative data isn't always numerical, and it's going to be numbers that you actually count or measure. So you're going to need to count the number of values, or you're going to measure the number. This is always numerical, and it's not subjective. So this would be things like weights and heights. It could be the number of credits students are taking this semester, because you have to count their credits. It could be the number of students in a class or in class over the days of the week. Anything where you have to count it or measure it, that's quantitative. So these numbers, they mean something as a number. You can just replace them with some letter and be fine. Like I was mentioning, qualitative with the numbers 1, 2, 3, 4. We could have done that with A, B, C, D, and it wouldn't have made any changes. But if I'm counting the number of students in a class, I can't just replace that with the letters. I could do that, but it'd be like a weird cipher, like trying to figure out what things are. No, just you keep a number, because quantitative data is going to always be a count or measure. So some examples, qualitative data, eye color, type of car, what else could we say? We could say lots of things. Let's maybe a number example would be like your house street number. It's not something you really counter and measure. It's a label. It's just a label to kind of help people find a spot on the street. Examples of quantitative data would be height, weight. We said the number of credits. So number of credits because you count how many credits someone has, how many credits they're taking from college courses. One example that I think kind of really clarifies the difference between the qualitative and quantitative when it comes to numerical data is like clothes sizings. When you get, I was thinking about jean sizes. Women's jeans and men's jeans are done differently. Women's, they do have numbers. You have the 10, the 20, whatever. They have these numbers, but they're not actual measurements. They're not actually sitting there measuring and saying, yeah, 10, this is 10 inches. No, it's just they use the label 10 for a certain size. Whereas if you go to jeans designed for men, they actually measure and they give you the waist, the 30, 35, 40, whatever the waist circumference is. So that's the big difference there. So you got to watch out for, is it actually a measurement? Like the men's jeans is actually a measurement, then it's quantitative. If it's just being used as a label, even though it's a number, it's still just a label, that's qualitative. So the women's jeans, they use those numbers that aren't actual measurements, so they're just labels, they're qualitative. So the type of data you work with determines a little bit like what kind of charts and graphs you work with. So we will use different charts and different graphs, qualitative versus quantitative. So it's important to know the difference between the two. And you'll see some homework questions where they want to determine, can you figure out what's qualitative data, what's quantitative data. When you work with quantitative data, we usually like to group it or do what we call binning, because you don't want to do each data value by itself. It's nice to have a cluster of values. That way we get our categories that we have over the range of values, and we don't have like a whole bunch of different options. We have like a limited number of options. You're probably familiar with this because you actually do this for your school work. So the grade ranges would be a set of bins, 0 to 59, 60, 69, 70, 79, 80, 89, 90, 100. Those are all bins, and then scores that are within those ranges fall in that category. The top one's A, B, C, D, and then F. So those are, categories. Those are bins for quantitative data. The frequency of the bin is the number of results that fall in that bin. So if we saw frequencies for categories in those bins, we do the same thing. We have the frequency. So let's, for example, maybe give a set of bins that would be useful for categorizing household yearly income. So one thing is you kind of want to do a regular amount. You see how we do, 10 points for each bin except for the lowest, because that one's kind of catch-all, right? Everything below 59. You should probably do the same thing with something like this. You probably want to go at certain ranges. You want to pick a number for your bin range that's going to give you, a few bins. So you're not just end up with like one or two. I wouldn't want to do like every $1 million, because not very many people are making more than $1 million. I have one huge bin at the bottom and then small bins at the top. But I also don't want to go too small. I want to go like 5,000, because then I have 0 to 5, I have 10, 10 to 15. It's going to be like really long. So I'd probably shoot for something that covers, good range, maybe something like 40,000. So let's try like 40,000. So we'd have 0 to 40,000 would be a bin. We'd have 40,000 to 80,000. We'd have 80,000 to 120,000. And eventually, at some point, we'd say, okay, we have enough bins. We want to do like a catch-all at the end. I think we might go one more before we do that. So maybe let's do 120,000 to 160,000. And we could do more, probably depending on the area you might decide, or how many bins you want. Here we have 1, 2, 3, 4 bins. We'd have one more at least if we did like 160,000 plus. So that'd be everybody over 160,000. Would be our last bin. So 5 bins. That's not a ton of categories, but it's not bad. You see it here. We had 1, 2, 3, 4, 5 for the grades. So 5 is probably decent. And we'd probably caught most of the people within the bottom range. We're going to have some people that are going to be over 160,000 for their, household yearly income, and it might actually be a lot. So maybe we are underdoing it. Maybe I should have done a bigger bin. But that's the idea. Sometimes the way you choose your bins can really change how your data looks. And so if you do your data and you realize the one column is just huge, you may think, okay, maybe I need to break it down into more bins and separate this more, or maybe I need to make my bins wider. This is kind of an open-ended question, but just to get the idea of this is what happens when you're working with quantitative data. You're not always given, a range of values you need to use. It's not like the grades where we already had that bin set, created. We had to come up with our own set of bins, and the bins you use can affect how your data looks, when you graph it and represent it. Okay. So one of the useful ways of displaying data is the bar graph. Bar graphs are used for qualitative data. Watch that, they're qualitative, which means this is where it's categories, qualities. It's not the numerical counts and measures. So a bar graph, we use sets of bars to show the frequencies. So we're showing frequency data. Longer bars, of course, mean higher frequencies. These bars drawn vertically or horizontally. You can take a bar graph and just turn it on your side and it works the exact same. And show the same data. So you'll see them on our side sometimes. And then you can also use these for relative frequency. So this one we have both. Here's an example. It's got frequency of grade, and it got relative frequency of, so it's actually, I think, the data we did earlier. So it's the same data. And you see it's labeled with the labels. The bars are all labeled. The frequencies are given, relative frequencies are given. So this is a bar graph showing categories, showing quantitative data. Notice the clear labels, right? Notice grades, frequencies, easy grade data. Without labels, graphs don't mean anything. So that's a really to notice. Get lazy when they're making a graph and they just don't include enough labels, or sometimes people don't pay attention to labels. You really got to watch labels because labels can tell you a lot about a graph and help you understand the data better. So really be careful with the labels. Important labels you should include the title caption. So the title, what usually describes it. If you need more explanation, there'll be a caption. It just explains what is being shown. A lot of times it also gives the data source. Vertical scale, so that's the scale on the side here. This is the vertical scale. It indicates the scale, so it tells you what you're counting by. So here we're counting by ones. Well, you could do the same chart and count by twos. It would look very different. So that can change things. You should have your tick marks so you can see where the lines are or lines across, and then the numbers should line up nicely. You should label what variable is being shown. So here we're looking at the frequency of the grade, the relative frequency of the grade. Horizontal scale, so the scale is across here. Categories are clearly labeled, so we can see what the different categories are. Don't need tick marks for qualitative, but you do want labels to describe what's going on. So here says grades. Bar graphs on the same chart on the same graph. If multiple data sets are displayed like that, if you have multiple bars of the bars, you need some kind of legend or key. Wow. I swear I wrote key, but man, typos. So when you do this, if you have multiple data sets, you should have a key. So here we only have one, but if we had the second set of bars on the same graph, we'd have to indicate some way how you know which was which. So the bar graph, again, qualitative data with the different categories and doing relative frequencies or frequencies on there. You should be able to read, or make bar graphs. So here actually gave us a set of data to use to make our own bar graph. It is numbers, but you'll notice these are just labels. So make a bar graph that shows the frequency for the following data. Clearly labeled, the data represents survey results from a restaurant. So the data here, 1 is just a low score, so like the worst food or worst experience. 5 is the highest score. How is the restaurant doing? So we want to clearly label. So first I'll just make sure I label that the survey results restaurant. 1 to 5. So 5 being the best, 1 being the worst. Because these are categories, we can go right down here and can, we're going to have a column for each category. So we're going to call for 1, 2, 3, 4, and 5. Each column is going to represent a category. To do these, it's helpful to get a count here. So let's go ahead and make a little frequency table first. So, result, and then the frequency. And of course, we're going to have 1, 2, 3, 4, and 5. And let's count those. So I have 1, 2, 3, 4, 4 ones. For 2s, I have 1, 2, 3 2s. For 3s, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 threes. For fours, I have 1, 2, 3 fours. For fives, I have 1, 2, 3, 4, 5, 6, 5. Okay. So now I can put that in here. Notice I do have to set my scale for the vertical, so I want to make sure I can fit everything. Since I have to go by 10, I don't want to count by ones here because I go 1, 2, 3, 4, 5, I'd run out of room. I could try twos, 2, 4, 6, 8, 10, and that's big enough. So let's go ahead and do that. So we're going to have 2, 4, 6, 8, 10. We're just going to make our bars tall enough. So for number 1, we have 4, so it has to go up to the 4. So that's going to go that tall. For 2, we have 3, so we're actually going to go up here because that's halfway to the 4 between the 2 and the 4. So we're going to go like that. 3 is 10, so 3 goes up all the way to 10. Okay, 4 is 3, so we're just going up here to 3. And 5 is 6, so we're going up here to 6. So now we have a bar chart where we can visually kind of see what's going on with our data. We can see that 3 is the tallest, we can see that 2 and 4 are tied for shortest. You can see which ones are, whether they're doing poorly or well. You can see most people say, yeah, they're average. A few people say they're better. They're more on the better side than the worst side because 5s are more common than 1s, but they're kind of around across the board a little bit too. So that's our bar chart. Again, these are the survey results. And here we would say these are the frequencies. Again, it's really important to clearly label your charts so that people know what they're looking at. What is this? What is the frequency of those survey results? These are the different categories for the survey results. So there you go. So you should be able to draw or read from a bar graph. You should know it's qualitative data that's being presented like that. Another type of chart we'll have is a pie chart. So pie charts also show qualitative data. So right here you can see qualitative data. And display in pie charts. We use pie charts primarily for relative frequencies. So notice that pie charts almost always for relative frequencies. That's really what we ever want to show. They do add to 100%. Give you a whole pie as 100%. The size of a wedge is proportional to the relative frequency. So the bigger the relative frequency, the bigger the size of that wedge. The correct angle is found by using this formula. So this is how you find the size of the wedge. You take the relative frequency times 360 degrees, of course 360 degrees because that's a full circle. Multiply that and we'll give you the wedge angle. The relative frequency is a percent or a fraction, so multiplying you'll get part of the 360. For example, below a chart based on grades from the first frequency chart, so this is the same grade set, we can see the wedge A spans an angle of 16%, times 360 degrees, which actually turns into 57.6. So this one's 57.6. This one that's only 8% is half of that. That's why it's half as big. Ones that are bigger, like 28%, are going to be bigger. And the biggest one is 36% because it's the biggest percentage. So each one of these is that angle we figured out by using that value times 360. Now, we're going to make our own pie chart right here real quick. This is data where I have 4 different groups, qualitative because there's groups labeled A, B, C, D, and then the frequencies for each group. So 20 in A, 10 in B, 40 in C, 10 in D. To do this, we do need relative frequencies. And to get relative frequency, we need to do a total. So let's first off figure out what the total is. Well, here I have 20 plus 10 is 30, plus 40 is 70, plus 10 is 80. So we have 80 total. So I do 20 out of 80, which ends up being 1/4 or 0.25. We do 10 out of 80, which is about half that. It ends up being 0.125, so 12.5%. 40 out of 80, which is half, or 50%, so 0.5. And then 10 out of 80, again, we already had that one. It's going to be that 0.125 or 12.5%. Now, to figure out our angles, we would do things like 360 times 0.25, 5, not 4, 0.25, which does give us, so you can multiply it out in your calculator, I guess I can show you that. So 360 times 0.25. We get 90 degrees. So the angle from 360 degrees went 90 of those degrees for that 25%. If I did 360 degrees times 0.125, I would get 45 degrees. The angle's half as big, so we're going to half as much. You can check in your calculator. And 360 degrees times 0.5, or 50%, is going to be 180 degrees. That's a half a circle. So using these, I'll grab a straight edge. She's left my last piece of paper. Make some straight lines on here. So let's start off with a straight line up and down. And I'll make the rest from there. So first off, I need a 90 degree. So it's going to be a nice right angle. So I'm going to go like this. And it's probably not perfect, but it's probably good enough for hand drawn. I'm not going to make you buy a protractor and measure out angles. You don't need a protractor for the exam. I will pick stuff where you can just read it, look at an angle, maybe calculate the degrees, but you're not going to need a protractor to draw a pie graph. I won't do that to you. So this first one, this would be 9 degrees. This is category A, which is 25%. We put the relative frequency, not the degrees. This is a right angle, right? This is a right angle, so it is 9 degrees. But we need just the percentage, the 25%. The next one is actually going to be 45. So instead of being 90, we're going to cut that in half and make it 45. So it looks something like this. And that would be category B. So 45 degree angle for category B because they had 12.5%. Next one was actually 180. It's half the circle. So if we just extend that line, so it goes on through the whole circle. So it's what do we call it, diameter. Then this is half your circle, and that would be category C because it was the biggest piece, 40 out of 80, so half of it, so 50%. And this last piece that's left over should be about the same as that one because it also should be 12.5%. So that's category D, 12.5%. There you go. That's how they make a pie graph. So we figure out the percentages for the relative frequencies for each one, and then just do those as a percentage of degrees. Multiply the decimal point into degrees, and it gives you your angles. In real life, you want to get this perfect. Yeah, you use a protractor or a program to draw on a computer. But I'm not going to make you do that. If you could just calculate the degrees, if you can look at a pie chart and tell me which what that means, that C has 50% of the results, A is 25% of the results, then you're good. That's what I'm looking for. Histograms. Now, you might be like, wait, that's the bar chart. We already talked about that. This is a little different because instead of a bar graph, this is a histogram. One of the main differences is that histograms work with quantitative data. So now we're looking at the numerical data, stuff that we counted and measured. And we usually display it with histograms. In fact, histograms are a really important part of statistics because a lot of data in statistics is quantitative and it's given in histograms. A histogram is essentially a bar graph with quantitative data. Bars on the histogram must follow the order of numerical categories. So a lot of times the numbers will have an order, so we'll keep them in order. There are types of bar graphs that don't have them in order, but those actually have different names. If it's a histogram, it'll be in order. The example though is the 5-point range of values for each bin. So yeah, we have our bins down here. So someone decided what the bins were, calculated how many frequency for each bin, put those in there, and that's how that works. We're going to use the table down here to correctly identify which histogram goes with that. So one thing you want to notice when you're looking at histograms, space between the bars isn't, usually don't have it, but if it is there, that actually means that you have an empty category. That's why there's no space until there's an empty category. The heights, again, tell you the numbers. So like here, I'd look at this and I'd say the first row should be empty. So it should see a space at the beginning. So like ones like this one don't work because it doesn't start with 0. So we can cross that off right for that. Then I should have 12, 15, which means I should be going from smaller to bigger. So I should be going with this one, right? Because that one's going from big to small. You can see again too that like this 5 does not make sense for 5, so that one doesn't work either. So that would be our answer. We start with a 0, and then we 12, 15, 5, 4, 2. So you should be able to kind of identify this is a histogram. It's working with quantitative data. It's got bins on the bottom. We're not different separate categories. The bars are not spaced. If there is a space, it's because it's empty. There's nothing in that category. That's how you should be able to kind of identify and work with the histogram. Line charts are used to display information very similar to histograms. We just use lines and dots instead of bars. One nice thing about these line charts is you can kind of follow the lines, see the trend a little bit easier maybe sometimes. Also, they're easy to graph multiple. If you look up line charts online, if you just Google line charts, you'll find most of the time they give you line charts, graphs with multiple lines. It's really nice for comparing like profits year after year, or patients trends. You know, if you look at year after year, because you can compare the different years on one chart and see how things have gone. So line charts are very similar. In fact, a lot of times you can make a bar chart and a line chart and do the same thing. You could just take, you know, make a bar here where that line is and go down here. Do the same thing here, just make a bar. And that would make you basically the bar chart for this. And you can see it would display the same set of data. You know, this is the same data, just as a bar chart versus a line chart. And so they're showing the same information, but just showing it in a different manner. Again, really useful when you want to show multiple sets of data overlapped on top of each other. Okay. Given this chart down here, we want to estimate sales for each month. So we're trying to figure out what the values are for here. So I'm looking at like November. So here in November, I can see it's close to 60,000, maybe a little bit over 60,000. You could maybe say like 61,000. These are in thousands, right? So that's why I'm going to say 61,000. So 61,000. January, it's about here. Looks like maybe 32, 33, somewhere in there. We're estimating. So if you're off by a couple of thousand, that's not a big deal. Oh. Sorry, a little distraction. Okay. So in March, we had a value right here. We're at about 12,000. And in June, right here, we're at 80,000. So that would be, you know, just the values for those values for the reading off the chart. So not a really super difficult section. I'm not expecting you to have all these charts and graphs like memorized, like exactly all the components or anything. You should just be able to read the charts, you know, find information on them, you know, create a basic bar graph or histogram, you know, maybe think about what makes sense for bins. You'll kind of see in the homework that that's really what we're doing. We're just identifying the values on these charts to be able to read these charts. As we go into, you know, chapter 6, we hit the bulk of what this section, this unit, we'll see that most of the times when we work with the data, we'll finish off by displaying it in a chart or graph of some sort. So that's it for this section. I will see you on the next one.